Welcome to today's lesson on 8.11a. Our lesson target is I will construct a scatter plot. So construct means to build or make a scatter plot, and describe the observed data as linear, nonlinear, or no association. So remember that the main categories for scatter plots are linear and nonlinear. And then within linear, we have positive and negative. And then within nonlinear, we have no association. Okay, so our essential question is, what does a positive slope mean for two variables? What does a negative slope mean for two variables? So remember that positive slope is the same thing as positive association. And the reason I say it's the same thing is because when we draw the trend line will have a positive slope, right? And then a negative slope would, of course, mean a negative association. Okay, so to answer the question, remember that in a positive association, or when a line has a positive slope, the independent variable increases while the dependent variable also increases, right? So the x and y are both increasing. Whereas in a negative slope or negative association, while one of the variables, usually the independent variable, usually the x is increasing, the y or the dependent variable will decrease. And we have our vocabulary words. They are the same as the other two lessons on scatter plots have been, but I'll go ahead and go over it. So bivariate data is data for two variables, a dependent variable y and an independent variable x that are related. Linear relationships, a straight line relationship between two variables. Negative linear association, when the value of one variable, usually y, tends to decrease as the value of the other variable, usually x, increases. No association, there is no relationship between the variables. Nonlinear association, a relationship between two variables where the direction and rate of change is not constant but changes. Outlier, a point that stands out from the data set because it is significantly different. Positive linear association, when the value of one variable, usually y, tends to increase as the value of the other variable, usually x, increases. Scatterplot, a set of points plotted on a coordinate plane. And lastly, trend line, a line on a graph that shows the association or the general direction between the data set. And so as you can see, we have pictures of the associations. So a positive linear association, my trend line would look something like this. A negative linear association, my trend line would look something like this. My trend line for the nonlinear association would look something like this. Remember, in a positive and negative linear association, this would actually be called the line of best fit because it is linear. And lastly, no association falls under the category of nonlinear, but as you can see, we wouldn't be able to draw a trend line for that one. Okay, so starting with our activity, it says one way to show the relationship between bivariate data is to create a graph that can represent the two variables. So for this specific graph, it says the School Spirit Club created a scatter plot using height as the x-coordinate and arm span as the y-coordinate. So we can see our x-axis is our height, and then our y-axis is our arm span. And so I'm gonna start off by drawing a line of best fit. So this is my line of best fit. Remember, your line of best fit has to go through as many points as possible. I know in this case, it only goes through 2 or close to 3. And it has to evenly split the ordered pairs or the points that are already on the graph, right? So to check, I always count how many points are above and below the line, or to the left or to the right of the line, however you want to think about it. So we have 2, 4, 6, 8, and then 2, 4, 6, 8. Okay, so that's a decent line. Sometimes I have to redraw it, like draw it multiple times just to get it right. So what patterns do you notice in the scatter plot? So after drawing my trend line, I can see that it is clearly a linear association. And then because the line is going upwards, I know it's a positive linear association. Okay, so then now from here, it says what conclusions can you reach about the relationship between the student's height and arm span? Okay, so we are gonna go ahead and write a statement using the sentence frame or the sentence stem as and usually we always start off with the independent variable. So in this case, the independent variable is the height in centimeters. So as the height in centimeters increases, our dependent variable is the arm span. So the arm span in centimeters also increases. Okay. And then for the second question, it says Miss Liu is trying to determine if there's a relationship between the math grade percent of her students and the time spent playing video games. She constructed the scatter plot for the number of hours her math students spent playing video games per weeknight, Monday through Thursday, and their grade percent in her math class. So of course, I'm gonna start off by drawing a trend line. So as you can see, the two things that we're comparing here are the time spent playing video games and then the math grades. Okay, so I am going to have to redraw this line of best fit because as you can see, there's 2 points below it and then like 6 above it. That is not any better. That is the same line. I'm really struggling with this one, as you can see. Okay, so this one's a little better because there's 3 dots that are clearly above it, only 2 below it. I mean, it might just be me, and this graph particularly is hard to draw a trend line. But question number 3 says circle the point 3.5 comma 80 on the scatter plot and have to explain the meaning of the point. Okay, so 3.5 comma 80, I know I'm going to look between the 3 and the 4. I'm going to look halfway and then I'm going to go up, right? So the only point that is at 3.5 is the 80, so that made that easy. And now I have to explain what that means, right? So 3.5 is my x coordinate and then the 80 is my y coordinate. So knowing that, I know that 3.5 represents the hours, right? Or the time spent playing video games. So when her student played video games for 3.5 hours, they had an 80%, because again, 80 represents the math grade, 80% as their math grade. Okay, so the number 4 is asking, what conclusions can you make about the relationship between math grade percent and time spent playing video games? Okay, so in terms of the conclusion, we can see that the relationship for the association is a negative linear association. So after identifying what the relationship is, we can write our as the sentence stem or the sentence frame. So our independent variable is the time spent playing video games. So as the time spent playing video games in hours increases, the math grade in percent decreases, because that is what a negative linear association is, right? As one increases, the other decreases, as one of the units or the variables. Okay, so we have question number 5. The scatter plot shows the fat and calories in 11 different foods. So this graph is comparing the fat and calories, and for this problem, we have to decide, A, does there seem to be a linear association between fat and calories of the food? So the first thing I'm going to do is I'm going to go ahead and draw my line of best fit. So let's check. We have 1, 2, 3 dots above, 1, 2, 3, 4, 5 dots below. Not my best line, but I can see a trend, or I can see the relationship. So yes, a positive linear association. Okay, B is saying, do any of the points appear to vary greatly from the other points? And then it says, if so, circle any outliers in the scatter plot and identify the outlier in the table. Okay, so the outlier, if we remember from the definition that we went over at the beginning, is the point or the ordered pair that stands out or is away from the rest, right? So we do have that right here. You can see it's right here. And then to determine what the ordered pair would be, I know that the x-coordinate is 25, so now I can see that the y-coordinate is 300. So I'm going to write there's one outlier. And then I'm going to write the coordinate 25, 300. Okay, lastly, number 6, the scatter plot shows the amount of time bookstore customers spent in the store and the amount of money they spent, right? And then A, does there seem to be a linear association between the time and money? So something that I noticed that students have been making a mistake about is that they try to force a trend line, right? Sometimes there is no trend line to be drawn. So some students I might see would draw the line like this, or they might draw the line like this. But in this case, there is no association. There's no linear association. So we're going to say nonlinear association, which is technically correct. And then to be more specific, we're going to say no association. Okay, so we have our we do. This one says the scatter plot shows the reading level. So we're comparing reading level and the height of 16 students in a district. Describe the association and describe the relationship between the reading level and height. Okay, so we're going to go ahead and draw our line of best fit. Okay, let's check the line. We have 2, 4, 6, 7 above, 2, 3. So that is not a good line. Let's try again. 1, 2, 3, 4, 5, 6 above, 2, 4, 6, 7 below. Okay, so I mean, this is a little bit better. Not the best. Remember that this point right here is called the outlier. And we can see through the trend line that this has a positive linear association. And then from here, we're going to write our statement as and we can see that our independent variable, if we label our graph X and Y, as the reading level increases, the height in inches also increases. So if we think about why this might be, well, your reading level is usually related to your grade level, right? Not all the time, but usually as you move on to the next grade, your reading level improves. So obviously, most times, an 8th grader is going to be taller than a 1st grader, a 2nd grader, a 3rd grader. So then our next we do problem, we're going to have to construct the scatter plot, or we're going to have to make it, right? So this one says the final question on a math test reads, how many hours did you spend studying for this test? The teacher records the number of hours each student studied and the grade the student received on the test. So we're going to go ahead and label our table. The hours spent studying, if we look on our graph, we can see it's already been labeled as the x-axis. So we're going to label X on top. And so that means that the test grade is our Y. So that means that X is our independent variable and Y is our dependent variable. So the test grade depends on the hours spent studying. Okay, so then next we're going to go ahead and have to graph the points. We have 0, 75. I'm going to start the origin and then I'm going to go up to 75. I can see that this graph is counting by 5s, right? Because we go from 70 to 80, so that's 10. But there's 2 boxes in between, or 2 units in between. So 10 divided by 2 is 5. So right in between is 75. Then we have 0.5, 80. So 0.5 on the x-axis is going to be between the 0 and the 1, halfway in between, go up to 80. Then we have 1, 80. So go to 1, go up to 80, go to 1, and then 85. Then we have 1.5 and 85. And then we have 1.5 and 95. And then we have 2 and 90. And then 3 and 100. And then lastly, we have 4 and 90. And then from here, we're going to have to go ahead and draw a line of best fit. So this one is not a good line. Let me try that again. This one's not much better. 1, 2, 1, 2, 3, 4. Well, this is the best I can do for now. So we did answer A. We made a scatter plot of the data. And what trend do we see? Well, the trend, is basically asking about the association, right? So some of the words that have come up for association included pattern, as well as I guess the only other word is trends. But we see that this is a linear and it's positive association. And next, C, describe the association between hours spent studying and test grades. Okay, so because of the trend line, we can more easily see the relationship, right? So we're going to write the as the statement. So as the hours spent studying increases, the test grade also increases. Okay, so let's answer D. So D is saying, do you think that studying for 10 hours would greatly increase a student's grade? So I know in class there was a lot of confusion about this because usually, and according to this association that we see, the more hours that you spend studying, the test grade would also improve. But as you can see right here in this outlier, right, 4 hours of studying is the most that a student studied in this class, and they only made a 90. The highest grade in the class was 100, but that student only studied for 3 hours. So yes, to a certain point, the more you study, the higher your grade's going to be. But if you study for 10 hours, it doesn't necessarily guarantee that you're going to do better, right? Because you might be confusing yourself when you're studying for that long. So we're going to say no. Studying for 10 hours would probably not greatly increase a student's grade. And then the rest of the worksheet is independent practice. Thank you so much for following along in today's lesson, and see you in the next one.